This is an anchor chain, but in fact, what you're seeing here is just one of the many pieces of an incredible and essential process for maritime navigation. For a vessel to remain firmly anchored in the open sea, it needs a sturdy system, and this forging process is what ensures the safety of large ships. In a world where technology advances rapidly, it's surprising how, even today, the forging of anchor chains remains a refined and powerful art that blends strength, precision, and history. Steel, once raw, is transformed into pieces that can bear tons, with each link meticulously molded to withstand the forces of the sea.
The process of manufacturing anchor chains begins with raw steel, usually in the form of ingots, which are large blocks of metal. These ingots, before becoming the links of the chain, undergo an intensive heating process. The high temperature is essential to make the steel malleable, allowing it to be shaped without losing its structural strength. When the steel is heated to temperatures above 1,000 degrees Celsius, it becomes more flexible and can be manipulated more easily. This initial step is crucial, as this is where the basic structure of the chain begins to form. The metal is placed in specialized furnaces and then transferred to large forging furnaces, where it is stretched and compressed by high-pressure machines. This first transformation not only shapes the metal, but also begins to determine the strength of the links. Steel, although it may seem like a simple material at first glance, has intrinsic qualities that ensure its durability. As the temperature and pressures are controlled, the steel becomes denser and more resistant, without losing the flexibility necessary to withstand the stresses and strains that anchor chains will endure at sea. After the initial transformation of the raw steel, the next crucial step in manufacturing anchor chains is forging at high temperatures. At this stage, the metal is placed in extremely high temperature furnaces, where it can reach over 1200 degrees Celsius. The idea behind heating the steel to such extreme temperatures is to make it malleable, allowing it to be worked without compromising its structural integrity. As the steel is heated, it becomes almost soft, allowing it to be handled and shaped by powerful machines and hydraulic furnaces. In this phase, the metal is pressed between large matrices or molds, forging the links of the chain. Each link begins to take shape, but the extreme heat also plays a crucial role in modifying the properties of the steel. The metal undergoes changes in its crystalline structure, which increases its resistance to fracture, fatigue, and corrosion, essential characteristics to ensure the durability of anchor chains when exposed to the marine environment.
Possibility. دي وصل لك.
Forging under these conditions requires precision, as temperature and pressure must be strictly controlled. If the metal is overheated or heated unevenly, the properties of the steel can be compromised, making it more prone to failure. For this, the forgers must be attentive to every detail, adjusting the heat according to the type of steel and the size of the piece. Once the metal has been shaped under pressure, it is precisely cooled to ensure that the steel structure remains intact and strong. After the forging process and the initial formation of the links, the inspection and refinement stage is essential to ensure that each link of the anchor chain meets the strict standards of quality and safety. Even though each link is forged with extreme precision, the nature of the work demands a detailed analysis of each individual piece, as any flaw, no matter how small, could compromise the entire operation of the anchor at sea. In this phase, the links are carefully inspected visually and physically. Advanced inspection techniques such as ultrasound, X-rays, and hardness testing are used to check for internal flaws, such as microcracks or air bubbles that may have formed during the forging process. These flaws, even invisible to the naked eye, can represent weak points that would affect the material's strength under tension. In addition to the technical inspection, the refinement process involves fine-tuning each link to ensure it fits perfectly into the chain. This may include adjusting the size and shape using precision machines so that each link has the necessary thickness and flexibility.